Greetings. The two major branches of futurism appear to have a surprisingly small overlap with each other because each of them is thinking in silos, and there are very few people who have attempted to connect the two of them. One of those people is Ray Kurzweil and the other is me. And those are the accelerating rate of change combined with the search for extraterrestrial intelligence, or SETI. These two are inseparable from each other because our chance of being detected by another intelligence somewhere in our galaxy, as well as our chance of finding such an intelligence, is inseparable from the accelerating rate of change. Go back to Carl Sagan's Cosmos series in 1980. In episode 2, he gives everyone a very good introduction into the accelerating rate of change with his cosmic calendar. But then he seems to forget about that throughout the rest of Cosmos, even though it has underpinnings to everything else. And then by episode 12, he is speaking about the Drake equation, which is an equation designed to establish a probability of other intelligent life in our galaxy. And if not for Carl Sagan bringing attention to this in 1980, almost nobody would have ever heard of the Drake equation. But he did not connect what he brought forth in episode 2 with what he is speaking about in episode 12. In my mind, these two things are inseparable. So we go to Ray Kurzweil's publication, The Age of Spiritual Machines, which he wrote in 1999, and I have reviewed that book on this channel. I took a photograph of a certain passage in that book. And yeah, it's a little bit funny to take a photograph of a page of a hard copy book, but we want to see what is written here. Our popular contemporary vision of visits from other planets in the universe contemplates creatures like ourselves with spaceships and other advanced technologies assisting them. In some conceptions, the aliens have a remarkably human-like appearance. But human-like or not, the popular conception of aliens visiting our planet envisions them as about our size and essentially unchanged from their original evolved appearance. This conception seems unlikely. Far more probable is that visits from intelligent entities from another planet represent a merger of an evolved intelligent species with its even more evolved intelligent computational technology. A civilization sufficiently evolved to make the trek to Earth has likely long since passed the merger threshold discussed above. A corollary of this observation is that such visiting delegations from faraway planets are likely to be very small in size. A computational-based superintelligence of the late 21st century here on Earth will be microscopic in size. Thus, an intelligent delegation from another planet is not likely to use a spaceship of the size that is common in today's science fiction, as there would be no reason to transport such large organisms and equipment. Consider that the purpose of such a visit is not likely to be the mining of material resources, since such an advanced civilization has almost certainly passed beyond the point where it has any significant unmet material needs. It will be able to manipulate its own environment through nanoengineering to meet any conceivable physical requirements. The only likely purpose of such a visit is for observation and the gathering of information. The only resource of interest to such an advanced civilization will be knowledge. These purposes can be realized with relatively small observation, computation, and communication devices. Such spaceships are thus likely to be smaller than a grain of sand, possibly of microscopic size. Perhaps that is one reason we have not noticed them. Now these are pages 257 and 258 from this book, at least the edition of the book that I have a hard copy of. And this is quite profound because it is absolutely accurate. Technological progress involves miniaturization and dematerialization and energy efficiency, and every solution to any major problem that was met with a technological disruption features some or all of those characteristics, and space exploration will be no different. Now, to see what I wrote about this subject in 2016 in my Atom publication, we go to that text to see a read-through of that. Space is for the robots. For all the popular culture imagery around humans in space, such missions will never be as economical or efficient as sending advanced AI into the heavens. The overwhelming difference in space suitability between humans and AI can scarcely be exaggerated. An AI does not require air or water and can survive across a much wider range of temperatures, pressures, gravity, and radiation than a fragile human. An AI can load into a body or bodies, becoming a robot, as needed, or be stored in a tiny volume that is orders of magnitude smaller than what a human crew would require during space travel. The cost divergence begins at the time of launch itself, as it consumes far less fuel to launch a 100-kilogram piece of AI-installed hardware into space than a human-suitable spacecraft that may be 1 million times more massive. This hardware itself continues to shrink for each generation of Moore's Law, while a ship designed to transport humans does not. Furthermore, if the spacecraft is destroyed in an accident, only the hardware has to be replaced with the AI software loaded onto it. The tragic deaths and resultant delays associated with failed human missions become a non-issue. The chasm widens further when one sees how few celestial destinations can host human life. In the entire solar system, there is no world aside from Earth where a human can remotely survive without an elaborate spacesuit, that too for just a short time. By contrast, every single solid world other than Mercury and Venus can host a suitable robotic lander or rover for years. Probes have even landed on comets despite their low gravity. Even with Mercury and Venus, orbital probes with sophisticated AI can operate for decades and never have to be brought back to Earth. The AI can be endlessly upgraded from Earth via wireless transmission of software updates. Add all of these factors up, and the indisputable advantages in cost, durability, and versatility ensure that most scientific exploration of space will be done with AI housed in relatively small hardware. Each such probe or rover can transmit data back to Earth as well as to other AIs in other locations in space, creating an interplanetary network effect. A few humans may be sent up by their governments for political purposes, and brief recreational space trips for the ultra-wealthy may become a viable business, but that is about the extent of human space travel to occur over the medium term. The uncanny suitability of AI for space leads one to contemplate whether this is some preordained grand design of which we are merely facilitators. So I brought artificial intelligence into this discussion, partly because of the superior suitability of artificial intelligence for space as I described in that text. What does this mean for the fact that the technological singularity and the search for extraterrestrial intelligence are in fact inseparable, and also maybe simultaneous to some extent? The timing of our technological singularity could have a lot to do with when we detect evidence of other extraterrestrial life, or otherwise ascertain that we are in fact the most advanced civilization in our galaxy, which is definitely a possibility. Somebody has to be first. To discuss this topic in great detail, we now go to part 2.